How many people have you touched today? I don't mean shaking hands. I don't mean bumping shoulders on a busy street. I mean touched in the deepest, most literal, physical sense, atom to atom. Because if I told you that right now, sitting where you are inside your lungs, there are atoms that once belonged to Cleopatra, you would probably smile politely and assume I was being poetic. And if I told you there are atoms from Julius Caesar in there too, and from Genghis Khan, and from every single human being who lived more than a couple of centuries ago, you would say, come on, Feynman. That's a nice metaphor, but it isn't physics, except it is physics, and I can prove it with nothing fancier than counting. Let us start with the most boring event in the history of your body. You just took a breath. One breath. In and out. You do it about 15 times a minute without thinking. It is so unremarkable that you have never once in your life been impressed by it. But that single breath, that little puff of air you just pulled into your chest, contains a number of molecules so absurdly large that most people have never encountered a number like it, and wouldn't know what to do with it if they did. One breath of air holds roughly 25,000 billion molecules. Let me try that again, because those words slide right past you. 25, followed by 21 zeros. In the language physicists use, about 2.5 times 10 to the 22nd power. I want you to feel how big that number is, because your brain is going to try to file it away as just another big number, and that would be a mistake. Think of it this way. Suppose you had a jar full of marbles, and each marble represented one molecule in your breath. How big would that jar need to be? Well, a standard glass marble is about 1 centimeter across. 25,000 billion marbles, each a centimeter wide, packed together, would fill a volume roughly the size of the Earth. Not a house, not a city, the entire planet. That is how many molecules you just inhaled. Or think of it with time. If you sat down and tried to count those molecules, one per second, no sleeping, no eating, no breaks, you would still be counting long after our sun exhausted its fuel and went dark. Not just our sun, every star in the Milky Way would burn out before you finished. The universe itself might not last long enough depending on which cosmological model you trust. That is what sits inside your lungs right now. One unremarkable breath. Good. Hold that number somewhere safe. We are going to need it. Now, how big is the atmosphere? Not in miles or kilometers, in molecules. If you could somehow count every single molecule of air wrapped around the Earth from the pavement to the edge of space, you would get roughly 10 to the 44th power, a 1 followed by 44 zeros. That is an incomprehensibly large number. It dwarfs the number of molecules in a single breath, the way the ocean dwarfs a teacup. So what fraction of the entire atmosphere passes through your lungs in one breath? Divide one number by the other, and you get something like 1 part in 10 to the 22nd power. In plain language, each breath samples about 1/10 billion trillionth of the whole atmosphere. That is small, that is spectacularly, laughably small. One breath barely scratches the surface. You might be tempted to stop here and conclude that breathing is trivial, that your lungs barely interact with the wider world. That would be a perfectly sensible conclusion. It would also be completely wrong, because I have not told you about the other person yet. Let me introduce Julius Caesar. Not because he matters more than anyone else, but because he is famous. He has been dead for a very long time, and that combination is useful. Caesar lived roughly 56 years. During those years, he breathed in and out 15 or so times a minute, day and night, for 5.5 decades. Over his entire lifetime, Caesar took approximately 200 million breaths. Each of those breaths contained the same 25,000 billion molecules as yours. So the total number of air molecules that passed through Caesar's lungs across his whole life is about 200 million times 25,000 billion. That gives us roughly 5 times 10 to the 30th power, 5 followed by 30 zeros. That is the number of molecules Caesar personally exhaled back into the atmosphere. Compare that to the total atmosphere, 10 to the 44, and you find that about 1 molecule in every 20 trillion floating around in our atmosphere was once inside Julius Caesar's lungs. 1 in 20 trillion. Now I know what you are thinking. 1 in 20 trillion sounds impossibly rare. Like trying to find one specific fish in all the oceans on Earth. And if you were fishing with a tiny hook, pulling up one fish at a time, you would never find it. You could fish for 1,000,000 years and never get lucky. But you are not fishing with a hook. You are fishing with a net the size of a continent. Remember the number I told you to hold? Every breath you take scoops up 25,000 billion molecules at once. That is not a hook, that is a dragnet. So let us do the multiplication, because this is where the magic happens, and I want you to see it happen in slow motion. You have 25,000 billion molecules in your breath. Each one has a 1 in 20 trillion chance of having been in Caesar's lungs. When you multiply a very small probability by a very large number of trials, what you get is not a small answer. You get a big one. The expected number comes out to roughly 1.2 billion. Let me say that again slowly. 1 billion molecules. From Caesar. In a single breath. Not over the course of a year. Not over the course of your life. In this breath. The one you just took 3 seconds ago while sitting there listening to me. About 1 billion molecules rattling around inside your chest once rattled around inside Julius Caesar. And that is not a rough guess or a hand-wavy estimate. The physics of this calculation is solid. It relies on 3 things, each of which we can verify independently. First, we know how many molecules are in a volume of gas. That comes straight from Avogadro's number, which has been measured to extraordinary precision. Second, we know the total mass of the atmosphere, which comes from barometric pressure measurements and is also well established. Third, we need the atmosphere to be well mixed, which I have not shown you yet, but I will. Given those 3 facts, the arithmetic is inescapable. That is not a metaphor. That is not a poetic interpretation. That is counting. But I can already hear someone in the back of the room raising a hand. How do you know those molecules spread evenly? Maybe Caesar's breath just lingered around Rome. Maybe the air over the Mediterranean is full of his molecules, and the air over China has none. Fair question. And it deserves a proper answer, because this is actually fascinating physics in its own right. Have you ever walked into a kitchen right after someone burned toast? You were not in the kitchen when it happened, but you know instantly. You smell it the moment you come through the door. Within a few minutes you can smell it in the hallway. Give it an hour, the whole house reeks. That is molecular mixing. The molecules from that toast do not sit politely in one spot. They crash into other air molecules at ferocious speeds, something like 500 meters per second at room temperature, which is faster than most handgun bullets. And they do not fly in straight lines. They collide with other molecules billions of times every second, careening off in random new directions, zigzagging through the air in what we call a random walk. Now, a random walk is a funny thing. Imagine a drunk man stumbling out of a bar. He takes 1 step forward, then lurches to the left, then stumbles backward, then wobbles to the right. Each step is in a random direction. After 10 steps, he has not gone very far from where he started. After 100 steps, he has drifted a bit further, but not nearly as far as if he had walked in a straight line. Molecules do the same thing. Despite zipping along at 500 meters per second, a single molecule making random turns billions of times per second takes a long time to cross even a modest room through diffusion alone. But the atmosphere does not rely on diffusion alone. Thank goodness, because if it did, Caesar's breath would still be concentrated over Italy. What the atmosphere has is something far more powerful. It has wind. Enormous, planet-spanning conveyor belts of moving air. Trade winds sweep across the tropics. Jet streams circle the planet at 200 miles per hour or more at high altitude. Monsoon systems haul vast columns of air from ocean to continent and back. Thunderstorms punch air from the surface all the way to the tropopause and then dump it sideways. The atmosphere is a churning, restless, 3-dimensional mixing machine that never takes a day off. A molecule exhaled in Rome today will be scattered across Western Europe within a few days. Within a couple of weeks, it has spread across the entire northern hemisphere. Give it a year, maybe 2, and it is distributed more or less uniformly around the whole globe. The atmosphere mixes itself thoroughly on a time scale of roughly 1 to 2 years. Caesar has been dead for more than 2,000 years. His molecules have been through over 1,000 complete atmospheric reshuffles. They are everywhere. Spread as evenly as salt dissolved in a warm bath. But more evenly, actually, because the bath eventually settles. The atmosphere never does. So the math holds, the mixing checks out, and the conclusion is as startling as I promised. Every breath you take contains about 1 billion molecules that were once inside Julius Caesar. But now I want to show you why this is much bigger than a fun fact about one dead emperor. There was nothing special about Caesar. I only chose him because people recognize the name. The same calculation works for anyone. Cleopatra, Aristotle, Archimedes, a shepherd in Mongolia who never made it into any history book, a mother who lived along the Nile 5,000 years ago and whose name nobody will ever know. If they breathed for a normal human lifespan and they had been dead long enough for the atmosphere to mix, which only takes a few hundred years, then your lungs right now contain about 1 billion of their molecules too. And how many people have ever lived on this planet? The best estimates say roughly 100 billion. 100 billion people, each having contributed their share of molecules to the air. Now, you cannot simply multiply 1 billion by 100 billion because many of those molecules overlap. The same molecule passed through multiple people over the centuries. But the qualitative conclusion is unshakable. Every breath you draw is a molecular archive of human history. You are inhaling the exhaled air of essentially every human being who lived far enough in the past. Not some of them, not most of them, all of them. Let that settle for a moment. Every tyrant and every saint, every genius and every fool, every mother who ever sang a lullaby, and every soldier who ever died in a ditch, their molecules are mixed uniformly through the atmosphere, and you are scooping up 25,000 billion of them with every inhale. The atmosphere does not care about fame or obscurity. It does not sort molecules by the importance of the person who last breathed them. It just mixes everything together, impartially, relentlessly, and hands it back to whoever breathes next. Let us go deeper. Breathing is only the beginning. Your body is roughly 60% water, and that water does not stay put. You drink it in, and within hours it is being used, broken apart, recombined, excreted, evaporated. The water inside you right now is almost entirely different from the water that was there a month ago. Where does the old water go? Into rivers, into the ocean, into clouds, into rain falling on a field in another country, soaking into the roots of a plant, being eaten by someone who has never heard your name. The hydrological cycle is a vast, patient molecular exchange program, and it is older than human civilization by billions of years. Water evaporates from the Pacific, drifts over the Rockies, falls as snow in Colorado, melts in the spring, flows down a river, gets pumped into a city water system, fills a glass on someone's kitchen table, goes into a body, comes out as sweat on a July afternoon, evaporates again, and the whole thing starts over. It has been doing this for 4 billion years. The total volume of water on Earth is about 1.4 billion cubic kilometers. That sounds like a lot, and it is. But a single human body processes about 2 to 3 liters per day, maybe 1,000 liters a year, and over a lifetime that adds up to somewhere around 50,000 to 70,000 liters. Multiply that by 100 billion people across all of human history, and the same flavor of arithmetic takes over. Given enough mixing time, which for ocean surface waters is measured in centuries rather than the year or two it takes the atmosphere, the water molecules in your body have been through other people's bodies. Lots and lots of other people. And then there is carbon. This one is my favorite because it is the most intimate form of atomic recycling there is. Every carbon atom in your body right now was once something else. It was carbon dioxide in the atmosphere. Before that, it was part of a leaf that pulled it from the air through photosynthesis. Before that, it might have been dissolved in seawater, or locked in a limestone cliff, or drifting through volcanic gas. Carbon cycles through the biosphere on timescales that range from seasons to millennia, and the paths it takes are wonderfully tangled. You eat somewhere around 20 to 30 tons of food over the course of your life, and all of that food contains carbon that has been cycling through living things for as long as there have been living things. Some of the carbon atoms in your body right now were part of a fern in the Carboniferous period over 300 million years ago. Some were in the body of a fish that swam in a Devonian sea. Some sat in a glacier for 1,000 years, locked in frozen water, before melting and re-entering the biological game. And yes, some were in the bodies of other human beings, metabolized through the food chain, returned to the soil, taken up by plants, eaten again. The recycling is slower than atmospheric mixing, but far more intimate, because when a carbon atom enters your body through food, it does not just pass through the way air passes through your lungs. It becomes part of your muscle fibers, your cell membranes, your chromosomes. It participates in being you for weeks, months, sometimes years, before it moves on to become part of something else. So here is where we stand, and I want you to feel the weight of this. The air in your lungs contains molecules breathed by every person in history. The water in your cells has flowed through millions of other bodies. The carbon atoms forming your proteins and your chromosomes have been recycled through the biosphere since life began. You are, in the most literal, measurable, physical sense imaginable, made of other people, and not just people, everything that ever lived. The atoms obey no rule that says they must stay within the human species. An oxygen atom in your blood might have been dissolved in a raindrop that fell on a Jurassic forest. It might have been part of a water molecule consumed by a sauropod dinosaur 150 million years ago. When that animal exhaled or died or decomposed, the oxygen atom went back into the world and kept cycling. Through soil, through oceans, through the atmosphere, through other living things, and eventually through a long and winding road that nobody could ever trace in detail, into you. I sometimes imagine picking a single atom and giving it a biography. The autobiography of an oxygen atom. Chapter 1. Forged inside a massive star, billions of years before the Earth existed. Chapter 2. Floating in a primordial gas cloud. Chapter 3. Incorporated into a rocky planet orbiting a new yellow sun. And from there the chapters multiply. Part of the ocean, part of a single-celled organism, part of a coral reef, part of a raindrop, part of a redwood tree, part of a Roman centurion, part of the breath a child takes on the day she is born. One atom, billions of years, countless forms, and it is inside you right now, this moment, doing its job before it moves on to the next chapter. Most people hear this and they think it is a pleasant curiosity, a conversation piece for dinner parties. But I want to show you why it cuts much deeper than that. Think about what this means for the idea of identity. You feel like a solid, continuous thing. There is a you that has persisted since the day you were born. Same person at age 5, at age 20, at age 50. But the atoms tell a different story. The atoms in your body right now are almost entirely different from the atoms that were there 7 years ago. Some tissues turn over in days. Your stomach lining replaces itself within a week. Red blood cells last about 4 months. Even bone, which feels so permanent, so structural, slowly swaps out its calcium and phosphorus atoms over the course of a year or two. I like to think of it this way. You are like a wave in the ocean. Watch a wave rolling toward shore. It has a shape. It moves across the water. You can point to it and say, there it is, that is the wave. But the water itself is not traveling with the wave. New water flows up into the wave pattern, participates for a moment, rises, curls, and then falls out the back as the wave moves on. If you tagged a single water molecule with dye, you would see it bob up and down roughly in place while the wave passes through it. The wave is not made of any particular water. The wave is a pattern that water moves through. You are not made of any particular atoms. You are a pattern that atoms move through. The carbon in your fingernail today will be gone in months, replaced by new carbon from your next 100 meals. But your fingernail will still be there, same shape, same place, because the pattern persists even as the material flows through it. You are the pattern, you are the wave, the atoms are just the ocean. And this is not philosophy, this is not me being mystical. We can measure it. Scientists have fed people food containing heavy isotopes, rare versions of ordinary atoms that can be tracked with sensitive instruments. They watched those tagged atoms get incorporated into bone, into muscle tissue, into the brain itself. And then, weeks or months later, they watched the same atoms leave, excreted, exhaled, sweated out, replaced by new atoms from the next meal, the next glass of water, the next breath. The traffic of atoms through your body is constant, relentless, and complete. Over a decade, virtually every atom gets swapped, so here is the question that I think matters most. If your atoms are not yours, if they are just passing through, and if those same atoms have passed through countless other living things before you, then what exactly are you? You are not your atoms. You cannot be, because they are not permanent residents. They are visitors, guests who stay for a few weeks or a few years, and then move on. What persists is the arrangement, the organization, the pattern. You are the way that matter organizes itself right now in this particular configuration, and that pattern is what thinks, what feels, what remembers, what wonders about questions like this one. There is one more thing I want to leave you with, because we have been looking backward at all the people who came before, but you can run this calculation forward, and the result is just as staggering. The air molecules you are exhaling right now, this very moment, will disperse. They will mix into the atmosphere, just like Caesar's did. Within a year or two, they will be spread uniformly around the planet, and then every person on Earth will start breathing them in. 100 years from now, 200 years from now, every human being alive will carry atoms that were once inside your body. Not because you are important, not because you are famous, Not because you did anything remarkable, simply because you existed, and you breathe, and the numbers are what they are. The same arithmetic that puts Caesar's atoms in your lungs will put your atoms in the lungs of every person born 3 centuries from now. You will become part of their bodies, physically, atom by atom, whether they know it or not, whether they want it or not. Try following a single atom, just one, on its journey through time. Pick a nitrogen atom that is in your right thigh muscle at this moment. Within a few years, it will leave your body, probably excreted or exhaled as part of a waste molecule. It will end up in the soil where bacteria will process it, perhaps convert it to nitrate, which gets absorbed by the roots of a soybean plant in a field somewhere. The plant incorporates it into a protein. Someone eats the soybean. That nitrogen atom is now part of their liver. A few years later, it leaves again, cycles through more soil, more plants, more animals. Over centuries, it could pass through hundreds of living organisms. Trees, insects, cattle, children, always moving, always being something new, never resting. And that atom is not unusual. Every atom in your body is on a journey like that. They were somewhere before you, and they will be somewhere after you. Your body is a temporary gathering place, like a campfire where travelers sit together for one evening before heading off in different directions at dawn. People sometimes tell me that physics makes the world feel cold, that reducing everything to atoms and forces strips away meaning. I have never understood that objection. Look at what the atoms are actually doing. They are flowing through every living thing on Earth, connecting every human being who ever existed to every human being who ever will exist, in a physical chain that nothing can break. Not death, not time, not distance, not any border or boundary that human beings have ever drawn. The atoms just keep moving, keep mixing, keep building new patterns out of old material. Your grandmother's carbon is in a child being born tomorrow in a city you have never visited. A farmer who tilled a field by the Euphrates River 4,000 years ago, whose name was carved on no stone, whose face no one alive remembers. That farmer's atoms are in your bloodstream right now, carrying oxygen to your brain as you listen to me say this. That is not cold. That is the most connected picture of life I have ever encountered. And it is not something you have to take on faith or accept because someone told you so. It requires no faith, no speculation, no leaps, just the size of a number, and the patience to follow where it leads. So here is something to chew on, and I mean really chew on it. Do not just nod and move on. Take the number of molecules in a single breath. Multiply it by the number of breaths in a human lifetime. Compare that to the total number of molecules in the atmosphere. Do the division yourself. Grab a pencil and a piece of paper and see what falls out. I promise you the answer will not leave you alone. But so, it will follow you around for days. And every time you take a breath after that, you will feel, just for a moment, the weight of everyone who came before you, sitting right there in your chest.